already stole my intro, right? I'm a product manager at Tecton. I'll start off telling you a little bit about Tecton itself, because you probably haven't heard of us. So Tecton is what we call a feature platform. We came out of the group at Uber, building the ML platform there. And I've started selling this product to ML practitioners across the industry. Some of the great customers I have the privilege of working with include folks like Atlassian and Roblox and Progressive, just to name a few there. Our focus is helping teams build real-time ML applications. So what do we mean by real-time ML? It's usually anything that a customer might experience like on a website or an application. So think about where machine learning comes into play for recommendations, for pricing, for search. And these types of applications can greatly improve the user experience, but it's also high risk, right? Because you're on that critical path. It needs to be reliable. It needs to be fast. Compared to building a traditional application, real-time ML introduces some kind of unique requirements. First, machine learning is very data hungry, right? There's a whole bunch of different data sources that can help improve the performance of your algorithms. So data scientists want to bring in things from their data lake. They want to bring in things from like near real-time sources like Kafka, or even fresh application data. And on the other side, machine learning applications need to consume data in two very unique patterns. First, there is a training environment where you're going to be processing potentially tables with billions of rows of historical examples and maybe thousands of columns of different features that are used to represent user behavior. And obviously, when you're processing that much data, you care about throughput and efficiency, and that's things like Presto are great for that. On the flip side, in the serving environment, now we need to access a small amount of data really quickly. So a user's opening up their application, we want to make some prediction about their likely next behavior. We need to get the features about that user on like millisecond order timescale in order to not block their experience with the application. So this is the problem that Tecton is trying to solve, is like, how do you make those pipelines work for machine learning? And people were doing ML before Tecton came along. So usually you had this experience that I have illustrated up here on the left, where a data scientist is maybe working in their Jupyter notebook, using Presto to pull some data, use pandas to massage those features into the shape that they want, and finally get to a model that they're happy with. But now they need to replicate that data in a real-time environment. So they throw their Python notebook over the wall and hope some data engineers can faithfully recreate that same logic. In the best case, you lose a bunch of time with that throw it over the wall process. In the worst case, you might actually end up with a different logical implementation that will negatively impact the performance of your models. So Tecton comes in to help people build these feature pipelines that are really specific and purpose-built for machine learning. And our goal is to make it so that that data scientist only needs to write their feature once, and they can go straight from that training to the production environment. In the broader context, we think about Tecton as the feature platform that kind of sits between the underlying data platform and the downstream consumers of those features being models and ultimately the application itself. So I talked about how Tecton makes some purpose-built pipelines for machine learning, but there's also a lot of general purpose computation behind that. And so we don't rebuild the wheel there. We connect to different data platforms that our customers already have. And so that's why I'm talking with you all today, because we just recently added our integration with Athena. We previously had integrated with some other data platforms, including like Snowflake and Databricks. So what does that integration actually mean? I'll walk you through how Tecton creates these feature pipelines to begin with. So a data scientist is going to come to us, and they're going to write their feature definition in a Python file. You can kind of see there's like a little bit of SQL logic at the bottom and some other kind of annotations at the top. Tecton is going to take that feature definition file and kind of compiles that down into a pipeline. And ultimately, we are going to send some queries to Athena in this case to read that data out of their kind of Glue catalog, transform that source data into the actual features that should be consumed by the model, and persist it into the actual feature storage for later use. Now, when it comes time to actually assemble all those different features together into your training data set, the Tecton SDK uses Athena again. In this case, you can see that little box there where we're connecting the customer's Athena instance to pull together all those features that are in the offline storage bucket. And then on the flip side, once they're ready to put their application into production, then they'll just send some requests against our real-time API. So that's enough slides. I'm going to now actually kind of walk through that same process that I was just talking about, but with a live demo so I can prove that it's real and hopefully everything works as intended. So let's start off with an actual definition of what we call a feature view, which is kind of like a table that represents a group of features. And let's see if I can make that a little smaller. So again, we have kind of our SQL business logic. In this case, it's pretty simple. It's just selecting out some columns from the table. And then Tecton has some special sauce aggregations here. Really common pattern for machine learning features is these trailing time window aggregations. Things like how many clicks did a user do in the last 2 hours or 7 days. So we have some special logic to make these more efficient and easy to express. And then there's also some other things like I want this to be updated on a daily cadence, and I want to be kind of that feature logic to be backfilled through the beginning of the year. So this was one that was already created. Now I'm going to make a new one. Obviously, I'm not going to write that live. And sorry about that. What did I click on? This case, we're just, it's kind of similar. We're just creating some new aggregations. So now that I've updated my file, I can come over to Tecton or the command line, and I run Tecton apply. It's meant to kind of evoke Terraform apply, and it's diffing what logic I have in my local Python files against what's in the remote production environment. So we'll give that a second to run. OK, so you can see here that it detected my logic change. It's also telling me that it's going to kick off a bunch of these queries to backfill that data. And then going forward, Tecton's going to run an additional query every day in order to get that latest data. So I will push that through. And now we can hop over to the Tecton web interface. And so you can see I just pushed through and apply right here. And I've created this new feature view. Most interesting for this talk, we can also come and see in this UI that, well, it's still spinning up. But it's going to start trying to fill in all this historical data. I can go look at a different feature that was previously calculated. And we can see that it ran all these historical jobs to populate that old data. All right, so now we have some some data that's in the feature store itself. I'll show you what it's like to train a model with Tecton. So we'll start off. Oh, that's not a good start. What did I do? Let me see if this fixes it. All right, so we'll get these running. Then the first cell, so I grabbed a handle on the Tecton SDK, and in the first cell that's running, I'm just going to look out kind of the output of one of those feature views. And we can kind of look at some of the samples that are already in the system. So this corresponds if I go to this feature view that we already created previously. And we can see that for this book ID here, I have a couple of different features, like how many ratings happened in the last 7 days and the last 30 days. But that's not enough to train a model. I want a bunch of different features in my training data set. So now we're going to move on to collecting a bunch of labels. So we have users and a book and what that user rated the book. And we're going to train a model to predict, given a user and a book, what rating are they going to assign that book. So given this set of labels as inputs, I am now going to pass that in, again, to the Tecton interface, and it's going to join a bunch of different features against those training values. So we can see that just completed. Now I have the book and the user and a whole bunch of features that have been joined on here. We can actually, because I said our SDK is connected to Athena to run this, we can actually come in here and look at the query that Tecton compiled. And you can see that it's actually maybe not trivial. There's a lot of logic that goes into this. And what is happening under the hood is Tecton is doing what we call a point-in-time join. So I have some nice future data in here, but we're saying, as of January 1st, 2023, what were all the feature values at that time? And Tecton is doing these as-of joins across a bunch of different tables to help these data scientists construct their training data sets. Finally, one last thing, I promised that without rewriting my features, I'd be able to access it in real time. So I'm going to come back and run this curl command that hits against my HTTP endpoint. And I'm going to say, I want features for this user and this book. And it's going to come back with just that single row in this case. And it has all the features that I would need to feed into my model for real-time inference. And it's saying it responded in 13 milliseconds. Oh, that's 130. Let's give that another run. There we go. Now it's a little warmed up. It responded in 20 milliseconds, which is not so bad, if I say so myself. So that's it. That's the whirlwind tour, right? I showed how a data scientist can come to Tecton and author features in their features as code interface, and then how we turn that definition into a pipeline that makes that feature data available for both training and serving without having to do any additional engineering on top of that. So I think lastly, I'd be remiss. You can come to tecton.ai to learn more about what we do, or just email me. I imagine most of you are more on the data side than the ML side, so that means you probably, I'd love to work with you all. We're always hiring, so just shoot me an email if that sounds interesting to you. With that, open it up to any questions or anything else.
Question, so are you using any feature stores such as Hopsworks or Feast, or is that part of Athena?
So Tecton is a feature store. So you might say Hopsworks is a competitor of ours. Maybe I'll kind of come back to this slide. So Tecton is a feature store, and kind of I'm showing the internals of Tecton here. Okay. And Athena ultimately is a part of it where we actually run the underlying queries. But yeah, it's a great question. Anybody else? All right. Thank you very much.